Bismillahirrahmanirrahim. Rabbi shrah li sadri wa yassir li amri wa hlul 'uqdatan min lisani yafqahu qawli. In the name of Allah, the most beneficent and full. Today, I will talk about the dynamic problem and how, what should be the statement for those who are teaching the subject of operational research to civil engineering student. This may be the statement that can apply, just can justify how to explain the students about civil engineering problems in civil engineering statement. When I say solving civil engineering problem, I may, may, may be of an option that this this is not a civil engineering problem, but this statement will can relate this problem with the civil engineering problem. So let's start. A concrete mix supplier has introduced his business in a new city. After a detailed survey, he identified three housing societies in which there is a bulk construction work taking place. He has hired services of 9 sales engineers to get optimize his profit. We need to use dynamic programming technique to find a maximum profit by deputation of 9 representatives in different societies for promotion of his business. The given metric says that by applying no representative or by applying one representative and by applying 9 this is the profit he is getting, obviously in million rupees. What we need to identify again is to optimize. The first step is we have to add society 1 and society 2, maximum profits of society A and society 2. The dynamic problem, what we do, we write the society 1 in the row wise and we put society 2 in the column wise, like we can see with this arrow. Now, the numbers are added metric wise. For instance, you can see that the profit from housing society 0 and housing society 1 is added, and that is 137 added by 122 gives 259. Similarly, this profit we can see is we add 137 and 90 to get 156. So in the first row of zeroth row of house society 2, we add all the combination. 137 is going to be added to all of this number. Like if I add 137, 94, it's 231. So it's 124. And last but not least, this. Similarly, all the subsequent rows will be added to all the subsequent column of this. So if I need, for instance, this is the fourth member, and then I combined 145 by 122. So this is how all these numbers we have gathered. First is, this is 15, I've added 15 by 40. But mind you, we always need to have, you can see these are making steps. So these making steps is because we are getting 9 each time. So the first row, 0 plus 9 is 9. That's why it's 9. We have added at 9. This is 9. So we add 1 and 8 to get 9. That's why we have stopped. If you would have added this number as well, say this will be 10 people. Actually, we need to optimize with the 9 people. For instance, 5 will stop at 4. So again, this 5 and this 4 become 9. as you can see, for the ninth, I've only added 135 and 122 to become 257. So that's why you will see this diagonal, and this will reduce. And this is because of the problem statement. If the problem statement would have suggested 10, then obviously we would have added one more at this row again. But then the number would have been 10 here as well. So this is how I've done. And for the sake of understanding what I've done, I've given different colors so that we can understand this diagonal. So once you do that, now you have to go diagonal and select the maximum value among the diagonals. So obviously, so we'll see that uh, one thing I forgot to tell you, there are two ways of solving a dynamic problem. One is the forward method and the other is the backward method. The first stage, we always go for the forward method, that is we add number from 0 to 9 of one society to then add 0 to 1 to 9 from other society. It could be for the backward method, it could be from 9 to 0 and 9 to 0 as here. So whatever is that, the first stage can be a backward or a forward method, but it's better to use the forward method. And in the second stage, what we are going to do, we'll select the maximum value from this diagonal. So the first diagonal from 0 to 0 will select this value. This is already 259. Then we'll go this select this diagonal 137. We will have this diagonal, and what I mean to understand is that we'll go this diagonal. So this will be actually this is not 137. Actually, what you need to select now this for this diagonal, I'm sorry, this is the max value is 156. It's not 137. So I'll just correct it here. So what we are going to do is to select 137 and 156, which is highest, we write here. The first point we have write 259, then we write 156. The third value among the diagonal is we'll select 137, 34, and 200. So maximum of them is 200. So that's why you write 200 here. Then we'll select 173, 76, 78, and 278. When we go diagonally, we'll find 278 is the highest value. Similarly, I will go from this, I will go on this diagonal and find that 267 is the most highest value among these diagonal, the purple diagonal. Then when I say this is a maroon diagonal, then obviously I'm talking about the maximum value, and you find 261 as the maximum value. So based on this, I've highlighted what are the maximum value in each diagonal, and I've written like here. So this is the value. That's 285 is the highest value among my last diagonal, this diagonal. So that's why I've written that. Now, we have said that if there would have been two society, the maximum, if I have to select 9 member, distribute 9 member, then I could have said that maybe my combination is take 6 people, assign 6 people to society 1 and 3 people to society. So this is, but since we have been given a problem where we have to select among 3 society, that's why what we are going to do now, we have got this value from the diagonal, the maximum value from the diagonal. Now, for the third value to be added will go backward. That is, we start from, for the third society, we will add from 9, we get the value of society 3 in order to have an optimization again. Why? Because if I've said it 9 and this become 0, so we all have to always have to have 9 at the same place. That's why we say 9. If we have said 1 and then we say 0, then this could not be 1. This could not be 9. We always need 9. So what I'm going to do is we have reversed this 9. It says we have 0 at the bottom, so that's why 9 becomes 0 is 9. Similarly, 8 and this is 1, so that's why. In the bottom of this table, I've written that this is combination from 0 plus 0, this is 1. So again, this should be 1, this is 2, this is 3, this is 4, this is 5, 6, 7, 8, 9. So remember the math number 9. That should not be violated each of the time. And what you need to do is to add, obviously. Now, 0 from society 1 and 2 is this is the number, and we have to add society 3 again. We have to keep this thing, what I am going to every time, this to be 9. That's why we have gone for the backward method. So if we have gone backward method from the first value, then we have to apply forward method. So what we have done, whatever the value is given us for the uh, people employed, profit employed. So what we have done the reverse. So actually here I've written 40, and if you look at the table, given table, the 40 is for 9. Then I will write 136, so I will go from reverse order. That's why I called it is backward method. So when I do that, I will do that, this I've written, and now again this row is sum of 259 plus 40. So that's 299. This you can see, this 299 is the sum of 156 and 136. So this is how these values have been calculated. 322, actually it is sum of 239 and 83. So once you do that, we find the maximum, so combination of three values, the maximum profit comes out to be 408 millions. So we'll find that the maximum profit is 408 millions. But for getting 408 million, we have to apply this configuration. The configuration says 4 people have to be selected from the society 3 because this is 4 and we have got the values, maximum value from this column. And the rest 5 people we have to select in this configuration, which we are not going to select society 2 because it has 0 member, and this is actually society 2 plus society 1. So this one actually 5 will be selected from society 1. So we are not going to employ any engineer because the society 1 has society 2 is actually working well without uh, employing an engineer. And this practically it happens that maybe someone uh, already knows your brand of concrete and your business, and that's why maybe even without applying the employing the salesman or the engineer, people already know about your concrete, and that's why we don't need. It's better not to send people and utilize service in the society where you can have a maximum profit. We can say like this that society 3, if we or we entail 4 engineers for marketing, that will be very good thing. And we will need 5 people from to society 1. Maybe society 1 and society for the influence of society 1 and society 3 will is automatically influencing society 2. That's why we don't need. any member. So this is what about dynamic problem, solves any problem, and this is my idea here is always to present you the uh, statement that would be probably be applied while you are teaching this subject to civil engineering students. Thank you very much. Eh, that's it from my side on operation research. Maybe next time I will have some more problems. Thank you, Melvin. Thank you very much.